Hello, everyone. My name is Greg, as I've already been introduced. So today I'm going to be talking about Microfrontends and back. So what it means, it's a journey of a naive architect. That's how I made a little bit of a headline here. So the idea is pretty simple. A lot of times we make decisions that are made of hype. And we did that as well here at Cobira. But I wanted to give a bit of a caution before you go with the hype. Is in general, don't be naive, right? So maybe sounds a little bit negative, but I have a good intention in my heart. So let's dive into it. So what you will learn, let's start with the bit of an introduction. So what you will learn today is benefits of microfrontends and what microfrontends are. It's not very extensive on microfrontends. It's just a very brief introduction. I assume you've heard about it. If not, then of course there's tons of resources online, so you can read more about it and decide for yourself. And then I'm gonna also tell you something that not many people do, which are the consequences of these benefits. So we have faced those consequences ourselves, and I wanna share my experience with you. And then what is the alternative solution? What is the stuff that we came up with at Cobira? So let's dive into it. So there wouldn't be any presentation about microfrontends without that picture. If you ever Googled anything online, you probably have seen it. So a very brief introduction. So what are microfrontends? Microfrontends, on a nutshell, are just many front ends on one single page. On one single application. So the idea is very simple. You can have different teams that work on different parts of your website in separation. So think about it this way. Maybe I have a team product which uses Angular, and then they build this red frame border. And then I have a team checkout that works in React, and they work on the checkout items, the ones with the basket on top and the buy button. And then I might have a team Inspire, which deals with Vue, code base, and then they build, like, in this case, it would be a recommendation system. So this is a typical e-commerce setup. You come in, you want to buy a tractor, and then you can buy it. That's another team. And then you can get inspired and buy some extra stuff. So it could be like typical recommendation. People who bought this also bought that, right? So the idea is pretty simple. I don't want to go into very details. There is a lot of ways of actually implementing that. One way would be to use iframes. One way would be to use, post message to communicate in between. Another way could be use the module federation. It's an ongoing topic. It's getting, popular, and it's getting more diverse ways of actually implementing that. So it's going on and being developed. But the idea is very simple. It's actually not very innovative new idea. I mean, back in 15 years ago, there has been frame sets that work similarly to this. I mean, the concept was the same. So it's not fairly new, but it's actually using the new technology these days. So let's go and talk about the benefits of microfrontend. So when you build something, you want to hear the benefits of it. So why do I do it, right? And then let's talk about each one of them. So first of all and foremost is independent deployability. As your team grows, as you scale your development team, you might need to deploy each part of the website separately because, maybe, one team, depending on your model of hopefully you use Git. So depending on your Git model, maybe you use Git flow, or maybe you use feature branches, or maybe you use chunk-based development. Generally, idea is that one team, when they merge something to master or main branch, then it can turn out to be problematic for the rest of the team. So you want to deploy them independently so you do not affect each other's work. Then the next one is the polyglot. So idea is great. You have many frameworks. Many frameworks means easier access to the developers. Maybe you run out of Angular developers, then you want to fill up your team with the React developers. Or maybe some framework is better and faster than the other one. And then, you want to embrace that. You have a bigger pool of developers, you have a higher range of things you can do, and then you can get the benefit of each framework on the front end in this case. The second one is modularized and cohesive code base. So it's modularized because each micro frontend is a separate piece of code that is being developed and maintained separately. And then it's cohesive because you reduce the amounts of communication between the modules. So cohesion is really important concept because, you know, highly cohesive and loosely coupled, that's what you want to aim for, which means you want to reduce the amounts, the information points that exchange information. In a micro frontend, it's actually recommended not to talk too much between the modules, since you might, you know, I don't know, maybe use the iframe solution, then you don't really have a lot of choice to actually talk to. So it's highly cohesive as well. So it's really good. Then it's also about faster development environment. What it means is, you know, when I have a team that works on a product team or maybe a checkout, I don't want them to spin all my website, because, you know, when you get bigger and bigger, you might have, you know, 100,000 lines of code, 1 million lines of code, maybe tens of thousand lines of code. So then you need to create an environment and spin it up, and it can take a lot of time before you can do it, because, you know, single page applications need to build it first. So you can actually suffer from development time. The developers might wait a couple of minutes before they can be productive in your code, and then every refresh will take some time too. And also testing, you know, you don't want to test everything, so you want to test things in separation. So, you know, you want to keep it fast. And then independent teams, that's great, because each team deciding on their own frameworks, they can decide whatever they want to choose. They can decide if they want to experiment with new stuff, and then they do not affect, because they deploy independently, so they don't affect the work of the other people. So that all sounds great. And when you look at it, that's how the architect looks like. He's going to be like, yeah, that's so amazing, power to the people, let's get it done. And then we went ahead and did that. And then we realized, there are consequences of each of these benefits. So let's talk briefly about that. So these are the benefits I just mentioned before. And now, okay, you do the independent deployability. That's awesome. But how do you do testing? How do you actually develop things? So, you know, unit testing, hopefully you follow the pyramid of testing. You don't do the ice cream cone, which is the opposite of that. So how do you test that both, all these micro frontends work with each other? I mean, in a worst case, you're going to have a part of the website that just don't render. But on the other hand, I mean, you really want to make sure things work, right? So it can become problematic, because you need to invest into the integration testing. Maybe you want to go with end-to-end testing, but end-to-end testing wasn't really made for that. It's made for the whole user journey, clicking from end to end. But I mean, you know, it's a problem, right? We had a problem. Like, sure, we have a nice unit tested modules, but then making them work together is not that easy. And then infrastructure, you know, to deploy each of these micro frontends separately, those apps separately, you probably want to have set up different environments. You want to deploy it from the single Git. If you use Git monorepo, if you use Git multi-repo, then still you have to set up, you have to know which module goes where. So it becomes a bit of a problem as well. So you have to make sure that you have a good DevOps skills in your team, and then make sure it's being deployed separately. Then also the polyglot. A polyglot is great, but it also creates a slow website. So imagine you have those multiple frameworks, and all of them use different, you know, code base, right? So you just fetch a bit of a React, you fetch Angular, which is much bigger. React is a library, so you can fetch just stuff you want. But with Angular, not so much. Then Vue, maybe you want to use Svelte or whatever you want to use. So it's going to be, your website will become slow, because each client has to download this. And then when you want to optimize for mobile, it can get really, really big. So that's one of the problem. Another problem is architectural mess. I mean, how do you know how people actually code in between? Some people can code, you know, one style in React, and the other will code differently, use different architecture. So in Angular, so how do you actually get it done and make it consistent? Then also communication is a bit of a problem. So it depends on what kind of type of the website you have. What we have is the single page application that has a multiple connection to other modules. So when I click something in one place, it needs to react in another place. And pushing everything through post message or any other type of communication system using Microfrontends became actually problematic. So you really want to answer yourself, like, why do you do it? Do you do it for the performance reasons in terms of like independent deployability and stuff, or do you actually need to communicate between the modules? Because sure, you're going to get the modularized, but communication might become a problem issue. Then faster development, that's correct. I really love that. It's going to be faster. You're going to be building and testing each module in separation. But how about the shared libraries, right? So maybe you want to share CSS or your UI. Well, you're gonna probably redo those buttons in every single framework. Maybe you want to decide to use only CSS, but some frameworks might not support fully SCSS or CSS. So, it can become a challenge as well. So the shared libraries are sort of an ongoing topic in Microfrontends. And then independent team, true, but how about the consistency? How about things like, what do we do with a code base that is different in different places? What about the coding standards? Some people might decide to use JavaScript, the other TypeScript. How do you do that? Do you allow any? In JavaScript, it's pretty natural. And also, switching the teams in between is not very easy. Sure, you have one guy working in Angular and then decide, hey, I would like to try React. Sure, go ahead to another team, but then he goes in and he's pretty junior at that, right? So he has to learn that, which might be good for the developer, but might be a little bit more challenging for the actual product. Then also, what if your team change? Maybe all team decides to go to another company or something. Now you have to maintain it, and you might not have the skills to actually do that. So there is a bit of a counter benefit for this. This is a consequence. So then when you look at it, and you might look more like this. This is the naive architect made a bad choice, but don't worry. Let's get what we can actually do about it. So what we did in Kabira, first we went to the drawing board, and we said, as a architect would do, we talk about non-functional requirements and what do we want to achieve in terms of our technical stuff. So we went and we look at those benefits and we said, okay, sure, let's analyze each one of them and then decide for ourselves what we want to do. So we said, okay, we want to be able to deploy at least once. Independent deployability, true, but we don't need that much of the infrastructure. We might even go ahead and decide to do it only one time a day. We can use release train for this. So we still use the trunk-based development here, but we can also solve it. The quality issue with merging to main and not so good code, you can solve it with PR environment. So whenever you make a PR, you can spin up an environment that is short-lived just for the testing purposes. And then you can, click around on that environment and make sure the whole feature comes in tested before it can get merged. So there are ways to go around it, but yeah, we still would like to be able to deploy it once a day. Independent deployability, it's nice, but it's not must have. Then we go and say, okay, how about polyglot? Well, we actually don't like that too much. We decided, let's keep one framework. We want to keep one framework for many reasons. So we chose Angular because we are an Angular company. And then we decided, hey, we want to be the best Angular team in Poland, right? So we want to build everything around that. So we want to create skill sets. We want to create career paths around Angular. We want to be the best we can be in that framework. You can choose whatever it is for your company, but think wisely. If you really want to have multiple frameworks in your environment, it depends on how big you are. I believe if you like 50 developers, it's not too big, so you can still find a lot of skills. as people with a lot of skills, and then you can still hire a little bit of a meet people, and then you have a skill set to actually teach people those frameworks. So you can benefit from that, I believe, as well. So the next thing is, what do we want to do with the modularized and cohesive code base? So we definitely want to keep that approach. We want to have a modularized code base. But if you think about like a monolith or modular monolith, so there is a saying that in Microfrontends, if you cannot build a modular monolith, which is a well-defined modules in between different teams, then what makes you think you're gonna be very good at Microfrontends? You probably won't, because you don't understand the concept of modularization. So we realized the problem was not the framework we chose, the problem was the people. Sorry to say that, but we didn't understand how to build modular code base. So we started to look into that instead of just choosing the tool for the job, because the tool wouldn't solve it for us. So we decided, hey, we want to build well-defined modules, and then sub-modules as well. And then we want to split it into as small as pieces as possible. And then we want to have a cohesive code base, but that was a bit of a challenge because we didn't have really a solution of the market, of the shelf. So we just knew we had to build some communication system in between those modules to prevent tightly coupling of these modules. So, but we knew we're going to build a reactive single page application. So we need to have a really good communication protocol in between those modules. So that became a challenge. And then, yeah, sure, we really want to benefit from the faster development environment. And in regards to modular monolith, it's going to be really difficult. So we knew we had to decouple it somehow and then make it deployable and manageable separately. At least to be able to only build the piece of the code and test it in separation. We don't want to be our old setup consisted of Jest and Karma in Angular. So, whenever a developer wanted to test a small piece of code. So when it's unit testing, that's easy. But when it's sometimes, actually, this is also a bit of a challenging because you want to test only single class. You're probably going to build the whole application anyway. So Karma is going to build it. That's going to take some time. It could be even 1 minute, at not so powerful computer, and 1 minute, repeated 20 times a day or 30 times a day becomes a long thing. And now you multiply it by 30 developers. That's going to be pretty slow. And that's going to slow you down. So we really wanted, this is the key of what we wanted from the Microfrontends, to be able to build and test only what is needed. So that was very important for us, but without using the Microfrontends, of course. So then we said, okay, independent teams. Yes, we want to keep independent teams. We want the teams to work on their own piece of website, but we want to keep it consistent. So we want to have a company-wide standards in which we would enforce some of the rules. And then we would also shape our learning paths for new developers to actually learn and fast. So we created a lot of shared resources in which people can read. So things like a YouTube channel or whatever. And then we added a lot of value through that. But we wanted to have a common standards, and we didn't want to repeat and violate the don't repeat yourself principle as well. Okay, so that's a lot of information. So the question is what we have ended up doing, right? So we went with the NX. NX now is the monorepo setup. So we decided to go with monorepo from the very beginning anyway. So NX allows us to do a lot of cool stuff. I'm going to talk about that in the future, in a minute. And then we also went with event-driven architecture. So I'm going to show you what it means and what are the components of event-driven architecture. It's not a very new concept. It's used in a backend a lot of times. So we thought, hey, we can use that on the front end as well. So let's see what it ended up. So before I go into event-driven architecture, let's talk about NX and its terminology. So the idea is you have NX apps and NX libs. So NX app is, what is app? App is independent and testable and buildable and deployable. So NX gives you the tools where you can actually build apps that do not know about other apps. Okay, a little bit disclaimer that they might know, but in general, they are independent piece of code. So let's say I have a team that works on some piece of the website. They can decide to create a couple of apps, for example. And an app is a bigger container, and it needs to be very lightweight, and it needs to be small and use libs inside. But it's also testable in separation. It's buildable and deployable. So NX can solve a lot of infrastructure issues for us, and that's really great. And then what app contains are the libs. So what are the typical examples of the libs? So in our case, we have shared libraries. Those are the libraries that contains the UI for us and shared code. So the idea is we use the layered architecture model. Some teams can decide to use, we support really 4 or 5 different architectures. You might decide to go with CQS architecture, CQRS. You can use the state, typical NGRX or Redux kind of architecture. You can decide with the simple smart component and the service. You can decide to use with the hexagonal architecture. So we have a different approaches to it depending on the problem. And then every library can decide its own architecture. And then we have core libraries. And core libraries are different from the shared libraries. The idea is that core libraries are the core of your application. So an application layer will use core libraries and the UI layer will use the shared libraries. So concerns about the core libraries could be authentication, it could be security, it could be authorization, and all those kind of things which are shared in between different modules. So these are also shared libraries, but only for the application layer. Then, of course, the most important feature libraries. So feature libraries will be a smaller library that consists of the actual feature that the user can see. So a feature library will consist things like a container or smart components. It will not contain presentational components, that's the shared libraries. And it will also contain, you know, all your business logic. So we decoupled, we believe in clean architecture as well. So the idea is we want to keep our UI to be framework specific, but our domain and application should be framework agnostic. So we don't want to put our business rules in Angular components. We want to actually decouple that. So it allows us to switch and upgrade the framework pretty fast. So feature libraries will be those which are pure TypeScript code, pretty much. And then we also have event libraries. So it's sort of like a core, but the idea is that you want to share the events in between different libraries or maybe different apps. So this is where we have event libraries for separation. So it helps us with the dependency graph. I'm going to talk about that in a second. Okay, so what is EDA? EDA stands for event-driven architecture. So the idea is architecture based on events, as the name consists. So it allows you to have a loosely coupled, high cohesive modules. I'm going to show you the diagram just in a second, but for now, think about it this way. Wouldn't it be great if my modules wouldn't know about each other? It would have a strict single protocol to communicate between each other. It would be very reactive. As soon as I send an event, the other modules would know about it, and it would allow me to create different architectures in each of those modules. That's what we really wanted, and this is why we went with EDA. So we started to implement that using RxJS. You can decide to use whatever you want, but we really love RxJS because it's pretty much like you can use it everywhere in any JavaScript framework. And it also allows you to, react to things. So you have concepts like subscribers, which allows you to react to changes in another place. So it really gives this reactiveness to our architecture. So it's really great. Then also think about it like strategic framework. So this EDA is just like the way you communicate. So it's purely application level. but it does not influence technical architecture of each module. So we still want to have, okay, we have a new guy coming in and he decides to, use maybe a very simple architecture, like just a smart component. Or maybe he wants to use the state because he's really familiar with it. So we do not want to influence that decision by using IDA. We want to say, hey, there is a framework you can just include in your code. It's a core library. And then you can just decide, hey, you can just, if you want to send an event, you use this. If you want to handle the event, that's another thing. But everything inside, it's what you decide. Your team decides of what you want to be doing. And then a very important thing to remember, events are asynchronous. So be aware of things like eventual consistency. So this has been a bit of a challenge as well. So just a disclaimer, you really want to keep that in mind. So this is not synchronous. It's not like I send one thing and then, I can wait for the answer from another module. No, you have to change the way you think about it. So yeah, we went with this approach. So this is how it works. So we have a state, CQS and CQRS. I'm not going to go that much into detail about each one of these guys. But generally, these are different architectures that a team has chosen. So then we have a core authentication on the left, when we have core events, and then we have shared UI, and each one of these modules can include those, but they should not know about each other. So let's talk about the next component, which is the bus. This is the bus is the application event bus, which is just a means of communication. It can receive events and then send it further. So each module can have one of two different classes that it can use. It can use a dispatcher to dispatch the events, and it could use handlers to actually receive those events. We decided for this terminology, you can decide whatever you want to use, but the idea is these classes exist outside of your core application logic, but it lives inside the module. So you need to include the module that allows you to use both of these classes. So let's give it an example. Let's say I have the top module could be team product that decides to, switch in between the views and choose different product. Then it will send an event. That event will go into the event bus, and then event bus will know who subscribed for this type of event and push it forward. So then you can have two other modules that listen to this event, and then they can say, hey, if I receive an event of type whatever, then I need to do that instead. So they do not know necessarily about each other. The only contract in between is the event that they are aware. And of course, it requires you to do integration testing, but now it's much easier. It's because you can test just based on the contract. So event is a plain JavaScript object. It can be actually very often just an interface in TypeScript. So IDEA is very simple. It's sort of consumer based. We have a consumer driven contract. So the idea is the two lower modules define what they expect from the top module, and then the top module needs to send that. If the top module, which is the provider, sends something that is not in consistency with the payload that the two lower modules expect, it should fail. It should not be able to deploy that code. So we can easily test that using integration testing techniques, just like you use hopefully for your HTTP request with communication in the backend. It's pretty similar. So these are all the components. I'm gonna sum it up a little bit in just a second. And then, okay, so let's talk about, did we actually solve our problem? So these are all the benefits, and let's talk about each one of them. The independent deployability, yes, we solved that through NX app. So NX already provides us with the solution. We actually, to be honest, we tried to do it ourselves using the DevOps principles, but then we realized that's gonna cost us. We created some issues, and then some custom shell scripts and whatever. It was not very sound. So probably you can solve it using DevOps, but it's gonna cost you a lot of money to do it. So why don't you just take something already you know, off the shelf. So NX can solve this for you. Then polyglot. So we already decided we're going to use Angular only, so that's not an issue. Then modularized and cohesive code base. Actually, NX ships with something really cool, which is called dependency graph. So every time we have a meeting once a week, for example, that we talk about with other architects, then we can spawn our NX dependency graph. We can define some rules, and then we can say, hey, we have some, I don't know, circular dependencies, or the information doesn't flow correctly, or some module should be in core. So you can easily visualize it in the dependency graph. It's really great. And it can also show you in the code, we can see how many connection points do we have. And then we also use ESLint rules. So since we use a layered architecture approach, we have like application layer, domain layer, infrastructure, UI layer. And then we can say for each architecture, we have a different overridden rules, which will check our imported files on top of the Java or TypeScript file, and then it will tell, hey, you must not have a dependency on that layer because that's breaking the architectural principle. So it's pretty cool, actually, what we wrote, because it allows us to, you know, check for it already at CI time, so we don't have to manually check it every single import. That would be insane. And then we also have IDA itself, since we use the events, so it's highly cohesive. So it also allows us to only send events. You must not include any other modules in your module A. So it solves the problem for us. Then for the faster development, sure, NX, since we're using apps, it allows us to build in separation. So as a developer, I can build only the app I'm working on, and then we can use Jest. We're actually using Jest in comparison to Jasmine. It's a lot faster because it doesn't, you know, build all application, and it doesn't make it in the, you know, web environment. Of course, you can use headless Chrome or whatever, but generally it's a lot faster. There are some tricks though. It's not super all shiny. You might actually suffer through things like, you know, Jest might not cover some of the UI browser events, like could be drag and drop, or it could be, you know, some events being handled, but there are ways to go around that as well. And then independent teams, sure, since we build different modules in IDA, the modules don't know about each other. So the teams can decide on the architecture they want to build, and they also can decide on, you know, how they want to build it, and, you know, create it in separation. So it solves most of our issues. And when it's pretty standardized though. So if you want to change from one team to another, you can easily, let's say you have a junior developer or mid-level developer, you can put him on an easy architecture first. Once he masters all the UI principles and he masters the application layer, or maybe infrastructure as a service, in form of the services, then he can easily move to another more advanced architecture and become productive straight away. So now how we really felt about it. This is how we really felt about it, and this is the sense of achievement we had. So a bit of a disclaimer. So with great power comes great responsibility. Can you guess what's the next slide? Well, if you thought it's a Spider-Man, well, you were wrong. Sorry to disappoint you. So what I want to say, I'm not saying microfrontends are not solution for your problems. They are a solution for many problems. It's just that you have to think really deeply about what is the core of your issue. Is it the people that do not know how to use some of the goodies of the architectures? Or is that the technical problem because we are so big, we just have to scale it faster? So if it's the people, well, I would strongly encourage you to move towards educating and using another ways. And as I said, learn about modularized code base first. Once you know that, go ahead and go for microservices if you still face the problems. But don't think that Microfrontend will enforce some rules on top of you, because yes, it will solve maybe the modularized issue, but it will create a lot of other issues for you, like communication, all the stuff I mentioned before. So if your problem is technical, then use the pros and cons that I mentioned before and decide for yourself. It might be the solution, I'm not saying that, but be mindful about what you do. And then once, I really think that Microfrontends shine at scale. I really think that once you cross maybe 100 developers, or you have hundreds of developers and tens of development teams, it can really solve. But assuming you already tried the modularized monolith first, and maybe try the IDA first, and then move to Microfrontends if that's the only solution. So it could be different reasons. It could be a political situation in your company where you don't get to decide on many things in terms of release cycles. Then Microfrontends can actually help you. But in general, think about it like scale is when they really shine. So with that being said, let's sum up what you have learned today. So hopefully you learned what is event-driven architecture. It's been quite brief, but if you ever need some more info, let me know. But in general, the framework has been presented. So the event-driven architecture consists of 4 different components. One of it is the event, which is just a data transfer object. It just transfers the data. So make sure you don't put any logic in the events. Then event bus, which is communication in between. You can use behavior subject, replace subject, or whatever stuff you want to be using, but make sure it's asynchronous and make sure it's decoupled from the rest. Then you should use event dispatchers. So whenever you wanna have an application service that you can include in your component or in your states or in your command handlers or whatever it is, and then you want to dispatch those events. So event dispatcher will dispatch an event on the event bus, and then you want to have event handlers which allow you to fetch the subscribe to the event being published on event bus by its type. So it's also pretty important. Now, I hope you learned also what problems does the IDA solve for you that Microfrontends don't. If not, you might want to rewind to the earlier stage of my presentation. And then also, what are the benefits of using event-driven architecture? So with that being said, I hope you're gonna have. I hope you learned something. I hope you discovered something new. So I wish you a happy journey. If you ever wanna get in touch with me, you can find on YouTube or Twitter or Medium. I write a lot of articles, or just try to find me on Cobira website. So yeah, that's pretty much all for the presentation, and I give the voice to the studio.